All right, for homework number 15, the first question says find the value of the derivative if it exists at each indicated extremum. So if they're telling me that this 0.23 is an extremum, meaning it's a relative minimum in this case, or it's also the absolute minimum, then by definition that has to happen at a critical number. So I don't really have to do the math here to figure out that g prime at 2 should be 0. I could find g prime and plug in 2, and it should come out to 0. Find any critical numbers of the functions. Okay, so remember, critical numbers happen when f prime is equal to 0 or undefined. So let's find f prime first. It's 3x squared minus 6x. I can find critical numbers by setting that equal to 0 and factoring out a 3x. So I get critical numbers of 0 and 2. It doesn't ask us to do anything else with this. It's just those are potential relative extrema to go from there. Okay, number 15, same idea. So let's find h prime of x. And we're just within one unit circle. So the derivative of sine squared, remember that's something squared, and then it's a sine x function. So that's going to be 2 sine x times the derivative of sine, which is cosine x, technically times derivative of x, which is 1, plus the derivative of cosine, which is negative sine. Okay, so to find critical numbers, let's set this equal to 0 and clean it up a little bit. 2 sine x cosine x minus sine x. You can factor a sine x out of that, and that leaves you with 2 cosine x minus 1. This is now a trig equation to solve, so it could be that sine x equals 0, or it could be that 2 cosine x minus 1 equals 0, in which case cosine x equals add 1 divided by 2, 1/2. So when does sine x equal 0 around the unit circle? That's when the y-coordinate is 0. So that's at x equals 0 and pi. But remember, our interval that we're looking at does not include the endpoints 0 and 2 pi. So 0 I'm going to exclude. It's not really a critical number because we're looking at an open interval. Pi is in there, though. So x equals pi is a critical number. And when is cosine equal to 1/2? So the reference angle is pi over 3. And the quadrants are quadrants. Where is cosine positive? Quadrants 1 and 4. So pi over 3 is an answer. And then in quadrant 4, that's 5 pi over 3. Both of those are between 0 and 2 pi, so they're both getting included. All right, for the next exercise, it says, locate the absolute extrema of the function on the closed interval. So this is that extreme value theorem, which just says that we need to check the endpoints and the relative extrema. Remember, we made a little table in our notes to see where's the highest value and where's the lowest value. So let's find f prime of x first. That would be 3x squared minus 12. And remember, I should say, there are no discontinuities here, but you want to make sure that you make note of discontinuities so that you don't include them as relative extrema. Okay, so 3x squared minus 12. So a critical number, if I factor out a 3, I get x squared minus 4. So the critical numbers are plus or minus 2. So there's potential for a relative max or min at plus or minus 2. And the candidates that we're looking for, you don't have to write candidates, but the potential values for which we have absolute extrema are at the endpoints, so 0 and 4, or at the critical numbers, negative 2, positive 2. And then you're just plugging that into f of x. Make sure you go into the original function, not f prime, and plug in and see what you get. So if you put in 0, you get 0. If you put in 4, you get 64 minus 48, which is, 16. And if you plug in negative 2, you get negative 8 plus 24. Now that's also 16. And if you plug in 2, you get positive 8 minus 24. That's negative 16. So it just says locate the absolute extrema of the function. So I'm going to say there is a max at 16 or there's a max of 16 and there's a minimum of negative 16. If it said, I feel like our AP test is more explicit. It would say find the x values or find the points if they wanted both x and y. Then you would list both 4 and negative 2 as points or x values where we hit the max. Okay, same directions for number 23. So let's find y prime or dy dx. 3 times 2/3 is 2. X to the negative 1/3 minus 2. Remember, you do want to get a common denominator here. So this is 2 over x to the 1/3 minus 2. So you want to get this into one fraction. That's 2 minus x to the 1/3 all over, oh no, wait, sorry. That's 2 minus 2x to the 1/3 all over x to the 1/3. So this is dy dx. And if we're setting that equal to 0, then we get a critical number of x equals 1, right? Because if this is equal to 0, you'd subtract 2 divided by negative 2. And x equals 0. Are both of those numbers in the interval here? Yes. Let me go back. I didn't double check that. Oh, you know what? See, I didn't double check that, and I almost made a mistake here. So negative 2 is not in the interval. So that doesn't change my answer, but negative 2 gave me a maximum of 16. So if the question was on this interval, locate the absolute extrema, it's actually only at 4, there's a maximum, and at 2, there's a minimum. Okay, sorry about that. So both of these are in this closed interval. So again, our candidates are going to get listed out here, and we're going to plug into y this time. So the endpoints need to go in, and then one of the critical numbers is an endpoint, so that's fine. So we don't have to put it in twice. If I plug in negative 1 into the original y equals, I get 3 times, so negative 1 squared is 1, and then the cube root of that is also 1, minus 2 times negative 1, so that's 5. If I plug in 1, I get 3 minus 2, which is 1, and if I plug in 0, I get 0. So the minimum is 0, and the maximum is 5. Okay, for 27, same directions. Let's rewrite h of s so that it's s minus 2 to the negative 1. We're on the interval 0 to 1. H prime of s, so now I'm just thinking of this as power rule rather than quotient rule. So that's negative quantity s minus 2 to the negative 2. Now, technically, there's a little chain rule here, like the derivative of s minus 2 is 1. I like to get in the habit of thinking of that if there's something more than just a single variable here so that I'm on the lookout for it in case it's 2 minus s or something like that. Anyway, h prime of s is equal to negative 1 over s minus 2 squared. And so the critical number that I get here is s equals 2. Now, 2 is not in this endpoint, in this interval, excuse me. It's beyond the endpoint. So there's no potential for a relative extrema in this interval. We still have to do the work, though. So s and h of s, we still have to plug in the endpoints because remember, this is a continuous function on this closed interval. It is continuous everywhere but 2. And that means that we definitely are going to have a high and a low point. So when we plug in 0, we get negative 1/2. And when we plug in 1, we get 1 over negative 1. So the maximum is negative 1/2, and the minimum is negative 1. Remember, with negatives, the further down the negative number line you go, the smaller that number is. All right, let's round this section out with some trig. So let's find f prime. So remember, you have a cosine function, and then you also have to take the derivative of pi x. So the derivative of cosine is negative sine of pi x, and then we have to multiply that by the derivative of pi x, which is pi. And we'll clean that up. Okay, for critical numbers, we're setting this equal to 0. I guess I kind of haven't been showing that. I probably should. You can divide away the negative pi. That is just a constant that doesn't matter. I just want to get it out there so it doesn't look so bad. So we're looking for, okay, when is sine equal to 0? So we said that sine is equal to 0 when the angle is equal to 0 and when the angle is equal to pi. And the angle is not just x, it's pi x equals. So I always start with both, like two of the angles within one unit circle, and then solve. So if you divide by pi, you get x equals 0. If you divide this by pi, you get x equals 1. Now, our interval of interest is only 0 to 1/6. So 1, I'm going to toss that out. I'm not looking at that. But 0 counts. So our candidates here for x and f of x, our potential absolute extrema, are at the endpoints 0 and 1/6. And then I don't get anything extra because 0 is a critical number here. Right? So when I plug in 0 into cosine of pi x, that becomes cosine of 0, which is 1. And if I plug in 1/6, I get cosine of pi over 6, which of course is radical 3 over 2. And you do need to know which one is higher. Remember, radical 3 is 1 point something, and you're dividing it by 2. That's definitely smaller than 1. So the max is 1, and the absolute minimum on this interval is radical 3 over 2. Okay. For 37 through 40, locate the absolute extrema of the function, if any exist, over each interval. So this is a linear function. You could graph it if you want to. All of these involve 0 and 2. And if I were to find f prime, I would just get 2, right? So there are no critical numbers. So we're really just saying, okay, in general, let's just go ahead and plug in the endpoints, 0 and 2. So when we plug in 0, we get negative 3. And when we plug in 2, we get 4 minus 3 is 1, right? So negative 3 is a minimum, and 1 is a maximum. And then what they're doing on all of these parts is they're changing it. This is kind of like the beginning of our notes. So sometimes we have a closed interval, sometimes we have an open interval, or some combination between. So for part A, where it's 0 and 2, if you're considering both endpoints, then we can say, okay, yeah, there's a minimum of negative 3, that's at 0, and there's a maximum of 1. And then if we look at part B, excuse me, if we look at part B, now we're only including 0, but we're not including 2. There's an open circle at 2, 1. So there's still a minimum, negative 3, but there is no maximum because the maximum would have been at 2, and we're not including that point. So you kind of do that with each one. So 0 we're not including, but 2 we are. So that means now there's no minimum because there is no point at 0. And there is a maximum. The maximum is equal to 1. And for D, when it's an open interval, this little line segment between two open points, there's no max and min. I guess I have this. No, yeah, this is right. There's no max and min because you can never reach the highest point. It has to be a closed interval. You have to have closed circles to be able to find an absolute extremum. Which kind of brings us to this next one. So determine from the graph whether f has a minimum on the open interval. So a minimum, remember, don't overthink this. A minimum is just the lowest point, right? And whether it's actually a relative minimum or just the lowest point on the graph does not matter. So yeah, so if f is going from A to B, even though that interval is open, there is a lowest value here. It's right here. So yes, there is a minimum. We can't see what it is. I don't have any information about it, but it exists. Whereas here, because the lowest point on the graph ends in an open circle, there is no minimum. So if what would be the lowest point is open, then that point doesn't exist. Same directions with this one. So this would be the minimum, but it's an open circle. So there's no minimum here. And this one's kind of weird. It's not a continuous graph, but hey, right here, we do have a lowest point. The lowest point is right there. Yes, there's a minimum. Okay, true or false section. I kept my answers up here, so they're all true except the last one. And let's just kind of go through and sketch some examples here. So the maximum of a function is continuous, that is continuous on a closed interval, can occur at two different values. It just says can, not that it must occur at two different values. So yeah, so sketch something. Here's one of these like, degree 4 type polynomials, and I start it and stop it at a certain point, um, assuming my sketch is better and these are at the same height, then yeah, that could have 2 maximum points. So sure. And then for the next one, if a function is continuous on a closed interval, that's the key, then there has to be a minimum on the interval. So that's true as well. If the interval is closed, meaning it has a starting and a stopping point, it does not matter what happens in the middle. As long as you know it's continuous, it definitely has a lowest point. The problem is with graphs like this, where maybe there's a discontinuity and you don't know if the lowest point at the discontinuity is defined or not, right? You can't guarantee on this graph B, unless I can see the graph, I can't guarantee that this point is down here. So if the graph is continuous, I can't do anything to make this not have a minimum. It's either at a relative minimum or at an endpoint. 67 is true because x equals c is a critical number. And it should also be a critical number if all we do is vertically shift the graph. Because think about this. So critical number, let's just say that's the vertex of a parabola. So it's a critical number because that's the maximum. If all you do is shift the graph up k units, so now you're sitting, instead of sitting at, I think I wrote C here on my key, but instead of sitting at this value here, you're sitting at a value that's k higher. That's still going to have a maximum here at C. It's still going to be C. That's the location of that vertex. But then 68 is the only false one because if we shift things horizontally, this shifts the graph to the right, k units. So let's use a parabola again because it's an easy example to sketch out. So here's where the original maximum was. If I say shift this graph over k units so that now it's sitting over here at like C, whatever C plus k is, now the maximum of that graph is over here. It's not at the original C. So that's why that's false. Okay, that finishes this homework assignment. Please come into office hours and let me know if you have any questions on this.